Hello and welcome to another Math Minute in Calculus 2. We're still talking about series in Unit 7 in this video, and I wanted to take a few minutes to talk about convergence of a power series. This is one that students tend to struggle with in this unit. When I'm trying to determine the convergence of a power series, really I want to know what x values will result in a convergent series if I plug in that actual value for x in the power series. And so there's three options. One is it converges for every single x value that I plug in. And this usually, if I'm using the ratio test, it usually looks something like this, where I set up that ratio test, simplify and evaluate that limit, and I get 0. According to the ratio test, if I get a value less than 1 for any value, then the series converges. So that would mean if I get 0 no matter what the x value is, I will get a convergent series no matter what. Now this also works with the root test, so either one of those just kind of depends on the setup of the series, but either one of those can be used with the same result. And what this looks like is on the number line is every single value on that line centered around our value x naught from the power series is a spot where the series would converge for that x value. And in terms of what the interval of convergence is, well, that'd be everything, negative infinity to infinity, and the radius of that interval is also infinity. The next option is it diverges everywhere, except it will always converge at its x naught value. So with this one, I usually do the ratio or root test, and I get infinity. No matter what the x value is, this limit goes to infinity, which according to the ratio or root test means that the series diverges. The only exception to this is if I actually plugged in the x naught value, then I should get 0 in that case from simplifying inside there, and then that would be a spot of convergence. So what this looks like is it diverges everywhere except for that one spot. So my interval is really just a point at x naught, whatever that value is, and the radius of that interval is 0 because the interval is just a single point. The third option is the one that tends to be the most difficult though and the most work. If I get something other than one of those two cases, one of those two extremes. So any limit that I get that is not infinity or 0 falls into this third category. I'm going to get some interval that's centered around x naught, and if I subtract the radius, I get the left endpoint. If I add the radius, I get the right endpoint, which is why we write it like this here. And that looks something like this. We have some interval that will be centered around x naught, where the series converges, and then anything outside that interval is a spot where it diverges. And so this interval is just going to be that those two numbers there, and the radius is the distance from that center to either of the endpoints. Now, just to clarify, with that last one, when I do the ratio or root test, it doesn't tell me anything about the endpoints. And so there's an extra step that has to be done with whenever I get something other than, it converges everywhere, it converges just at one point, I have to test the endpoints. And this is the part that students miss a lot. They will stop at that last step and not take the time to test the endpoints. But this is a requirement to find all of the points where the series converges. So I'm going to do a quick example. I'm not going to run through all the details, just kind of the strategy behind this, behind these kinds of problems. So I have here a series that's centered around 2. Okay, this is my x naught value because it's the number subtracting from x inside that power of k there. So let's say I went through and I did the ratio test on this, and I got that the x values between 1 and 3 are convergent. And so now I don't know what's happening at 1 and at 3 though. And so I'm almost there, but I need to also test these endpoints. So I'm going to actually take those endpoints, plug it into the series. So in place of the x, I'm going to plug in 1 right here, and then simplify this. And I get this series here, looks like an alternating series. So I would run the alternating series test on this to see if it converges or not. And then I do the same thing with the other endpoint, plug in 3, simplify it. I get 1 over square root of k, which is just a p-series. So I would use a p-series test to determine whether this converges or diverges. Now I'm not going through all the steps here because this is meant to be a quick video, but you should get that the series converges at 1, and so I use a bracket on the 1 when I write my final answer, and diverges at 3, so I use parentheses for that one. Okay? So this is the extra steps that you want to take. You want to actually show all the steps of running the alternate series test and the p-series test to prove these two things. So these can be kind of long, but definitely important to finding your final answer.